Hello everyone, welcome to Prime Mathematics. So, so today we are going to talk about one of the question, which is our problem 1.1. Okay, so what this problem says? This problem says that limit n tending to infinity, in the numerator we have n square, and the denominator such kind of continued product has been given. So let's try to change this. So if we talk about this product first, suppose we have product as given by P. So say P is equals to n square plus 1 square, n square plus 2 square, and so on up to n square plus n square. And this entire expression has whole to the power 1 by n. So one can also write it in the form of continued product. What is the continued product? It can be written as pi. Pi denotes the continued product sum. So it can be written as from k equal to 1 to n, because our value change from 1, 2 and so on up to n. So this can be written in a simplified manner as n square plus k square whole raised to the power 1 by n. Now 1 by can be distributed over this. So if we just plug in the 1 by n over the internal part n square plus k square, we get pi from k equal to 1 to n square plus k square whole to the power 1 by n. Now as we know, if we take log on both the sides of this, so log p to the base e can be, this product can be changed into summation, because we know if suppose we have a series from k equal to 1 to n ak as s, and if we take log on both the sides, so log s to the base e is given by summation k equal to 1 to n log ak, right? Because if you open, it is a1 a2 in the product form, and if we take log, it would be log a1 plus log a2 and so on up to log an. So this way can be written similarly manner. If we take log on this, so we get summation from k equal to 1 to n log to the base e n square plus k square, n square plus k square whole to the power 1 by n. Now why the property of log 1 by n can be taken outside? So one can also write as summation k equal to 1 to n. It will be 1 by n dot log n square plus k square, right, to the base e. Right. Now if we just apply, or we can take common as n square from the internal, we get summation, actually it's log p to the base e is given by summation k equal to 1 to n. Now it can be written as 1 by n log n square 1 plus k by n whole square, right? Now further one can apply log m into n, so it can be further break out into summation k equal to 1 to n 1 by n log n square plus 1 by n log 1 plus k by n square, right? Now if we just distribute the summation, if we distribute this summation, what we'll get? After distributing this summation, we get 1 by n, or you can write as 2, because n square by the property of log 2 can be taken outside this, log n summation k equal to 1 to n, plus this can be written as summation k equal to 1 to n 1 by n log 1 plus k by n whole square, right? And now if you see that k equal to 1 to n means log n by n is independent of k, so it can be taken outside. So 1 will be the only term left on which the summation will be applied. So if we add 1 up to n times, what we get? 1 plus 1 up to n times is n itself. So therefore we get log p to the base e. 2 by n log n is a constant, so it will be taken out of the summation. Then summation of 1 for up to n time will be n. Then we get summation k equal to 1 to n 1 by n log 1 plus k by n whole square. If we observe this, n gets cancelled out. So therefore our log p to the base e is coming out to be, as this 2 can be taken in the power, so it will be log n square plus summation k equal to 1 to n 1 by n log 1 plus k by n whole square. So from this, what we get our p? So p, after removal of the log, this exponent e will be taken to the power of this. So it will be e whole to the power log n square plus summation k equal to 1 to n 1 by n log 1 plus k by n whole square. Now further, one can distribute the property of exponents, so it will be e to the power log n square plus e to the power multiplication, it will be in product summation k equal to 1 to n 1 by n log to the base e. The base e is very much important, right? So it will be e. Okay, so now further what? Further, it will be summation k equal to 1 log 1 plus k by n whole square to the base e, right? So this log e and gets cancelled out, so we get p equal to n square e whole to the power summation k equal to 1 to n 1 by n log 1 plus k by n whole square. Now using the value of this p, so therefore we can replace this denominator term. This can be written as limit n tending to infinity n square divided by, in the denominator part we have found the value of p as this, so we'll substitute this. So it will be n square dot e to the power summation k equal to 1 to n, then it will be 1 by n dot log 1 plus k by n whole square. Now if we see this n square gets n square cancelled out, now applying the Riemann sum means we are applying the limit over the power, so we get 1 over e power limit n tending to infinity summation k equal to 1 to n 1 by n dot log 1 plus k by n whole square. Now by the property of the Riemann limit of integration, we know that summation, we know summation k equal to 1 to n tending to infinity limit 1 by n dot log 1 plus k by n whole square can be converted into the definite integral of the form from 0 to 1, and 1 by n can be changed to dx, k by n will be replaced by x, so it will be log 1 plus x square. Now one need to find the integration of this, so we need to find this integration, so we will apply the Euler rule, right? So log 1 plus is our first function and 1 is our second function, so it will be log 1 plus x square dot integration of dx minus integration differentiation of first will be 2x by 1 plus x square, differentiation of first will be dx, and the entire limit is going from 0 to 1, right? So what we'll get, we will get what we get as log 1 plus x square dot x minus, now 1 plus integration of dx is x, so it will be 2x square upon 1 plus x square dx. Now one can do a manipulation simple to reduce this integral into a very simple integral form. So we have just add 1 and subtract 1. So therefore we'll get x log to the base e, right? 1 plus x square minus, it will be 2 integration of dx, and minus minus plus 2 dx integration 1 plus x square after distribution of 1 plus x over in each of the numerator part. So now one can solve as x log to the base e 1 plus x square minus 2x plus 2 tan inverse x, and limit going from 0 to 1. Now if we substitute the upper limit as 1, we will get what? We get log 2 to the base e, and then 1 here, it will be minus 2 plus 2 tan inverse 1 is pi by 4, right? So it will be 2 times of pi by 4. And if you substitute 0 to the entire term, will be 0 itself. So therefore after reduction of this, we get pi by 2, because 2 2s are 4, pi by 2 plus log 2 to the base e minus 2. This is our value of this. So therefore the original limit will be 1 upon e to the power pi by 2 plus log 2 to the base e minus 2. Now if we know exponent rule, if we just transfer this denominator exponential term over to the numerator term, so the entire power will be just have a negative sign inserted. So if we insert the negative sign in the power, we get negative pi by 2, negative log 2 to the base e, and plus 2. So therefore our further answer will be e to the power 2 minus pi by 2 negative log 2 to the base e. So let's see what our option matches. So whereby it is wait a minute, we can do a simple more reduction by the exponent rule. If we take this as one part, this as second part, so this can be broken into the division power form. So it will be e log 2 to the base e, and again it's cancelled out, so we get half e to the power 2 minus pi by 2. So therefore our correct answer will be C option, right? Thank you so much everyone.